Hello guys, welcome to the ASTRO. So in this Python tutorial on fitting linear regression on a scatter plot, so this tutorial is going to teach you 6 different methods to fit a line on a scatter plot and obtain its slope and intercept of a line y equal to mx plus c, and we will be also obtaining the error and uncertainty in the slope and intercept. So you can see here we have like 6 different methods. So method 1 is Scipy CURV fit, method 2 is nmp.polyfit, then third will be Scipy stats, and then fourth will be Astropy modeling, and then we will use lmfit, and then we will use SciKit learn. So these are like 6 different methods to do linear regression and obtain slope and intercept, and also the error in a fitted parameter. So let's do one by one. To do so, let's first import necessary library to do this task. So import libraries. So we will import NumPy for number Python, NumPy as np. So this will take care of your array, and we'll also import matplotlib dot pyplot as plt. Okay, so this and then we'll import from Scipy dot optimize import CURV fit. So this will be used to fit line, and this will be used to deal with plots. Okay, now so this much we have done. Now we will define our x and y data. So here define x data. So we define x data. So you can tell x equal to, or maybe you can just give here x data equal to np dot linear space. You can give from minus 10 to minus 10 to 10, and maybe you can go from minus 100 to 100, and you can guess a 50 data points. Okay, and then you can give y data equal to x data, and so here give y data as x data plus noise. Okay, so noise is basically your random numbers in those linear plot. So here we will do one thing. Here I will import. So here import random module and this will add noise. So this will add noise. So import random, so it will add noise in your y data. Okay, so if you plot here simple plot plt dot scatter, okay, and you can give your x data and your y data, and if you run the whole code Okay, so here you can see that the line is like simply linear plot. So we'll do this plot as a scatter. Okay, so for that here add some noise like here plus np dot random dot rand int and add some integer in those linear plot. Okay, so you can give, say I want to give 50 equal to the length of the x data, so you can give say 50 random data points, or maybe you can give here say 20 to 80 and 50 random integers. Okay, now plot this. Okay, so here you can see that this time your linear plot has been got some noise and it has been scattered compared to previous. Okay, so now you have to fit a line through it. Okay, so this plot, so this will plot it and this will show it. Okay, now this much we have done. Now fit it. Okay, so for fitting, go here and fit the line y equal to mx plus u. Okay, so for doing that we'll define a function, define say line, and you can give your variable as x data and or maybe you can define your variable x data, then slope and c is intercept. Okay, now here you can define that return x, or maybe just x data into, or like here m into x data plus c. So this is like returning a function. Okay, so now this is my done. Now so here you have define line function, and now fit the line. Okay, maybe like here fit line and obtained optimize parameter m and c. So for that type here CURV fit, or maybe you can do here say POPT and P covariance. So here POPT is your optimized parameter, so POPT is your optimize parameter, and P covariance is your 2x2 matrix, and like this is used for your computing to find error in M and C. Okay, so for that type here CURV fit and you can see this takes a function, so you can give your line, and then you can give your x data, y data, and your initial guess. Okay, so you can give say your x data, your y data, and you can give some initial guess p0. Okay, so p0 you can give, say I am giving slope as 1, and intercept you can give as 40, and give any number and run it, and then you can check it that what is your POPT. So this is your POPT, this is slope, and this is intercept, and you can also check your P covariance. Also the comma. Okay, so this is like 2 matrix, and this is like a symmetric matrix. Okay, like 1 2 equal to 2 1. So this diagonal element will be used to like compute error in M and C. So let's do it. Okay, so for that, this is like it has obtained parameter. Okay, obtained M and C. Now plot fitted line. Okay, so for that, type here plt dot plot. You can give your x data, and then you can pass your line, you can give x data, and then a star POPT. Now run it. Okay, so here you can see that there is a line passing through it, the blue dots. So this is like best fit line for this scatter plot. So you can give some line width to this plot. Say line width I can give 6, and I can give say color equal to red, and I can also increase the size for this plot. Can give say s equal to 250. Okay, so and I can also give color. So color equal to I can give green. Okay, so this is like our best fit line for this plot, and I can also give legend. So I can put here label equal to best fit line, and this is your label equal to, you can call it a scatter plot. Okay, so best fit line, or you can say fitted line such that Scipy. Okay, Scipy CURV fit. Then you can simply type here plt dot legend, and your job is done. Okay, so here you can see that you have fitted line, and fitted line is in the red color, and your scatter plot is in a green color. So this way you have obtained, and you can type here say print. So slope and intercept. So you can type here print slope and intercept such as C, slope such that M, and pass your POPT 0 and POPT 1. Run it. So here you got slope M and intercept C respectively. So this is your slope and this is your intercept for the fitted line. Now next will be to find error or error in M and C of fitted parameter. So let's do it. So error is basically your p covariance matrix. So this is your matrix and take its diagonal. So we'll type np dot diagonal p covariance. So this will return the 1 on at 2 matrix element and take its square root. Okay, so np dot sqrt, and so this will be your error. Okay, error in the slope and intercept. So this will give error in M and C. Now print it. So you can say print error in M and C. So you can pass here, you can give here error equal to then error 0 and then error 1. So run it. So here you got your slope intercept 1.02 and 29.05, and then you got your error in slope 0.04 and in intercept it's 2.72. So we have fitted line and we have obtained slope and intercept. You can also give label here plt dot x label, so x data, and similarly you can give y label plt dot y label y data, and you can give a title as method one Scipy CURV fit line. So this is our first method. What is wrong? There should be title, not title. Okay, so this is like your, there should be, go to the above before plt dot show, and now it's fine. Okay, so we have obtained the first method to fit a line y equal to mx plus c and obtain slope and intercept, and also find error using Scipy CURV fit method 1. So I hope this is the clear that how to do linear regression using Scipy CURV fit and how to obtain a slope and intercept, and also to find error in those slope and intercept. So next method will be to use numPy Polyfit and do the same thing and find its slope and intercept and also the error. So let's do it the second method. So to do using numPy Polyfit, we will here obtain fit parameters. So type here POPT1 and P covariance 1. Okay, so and type here np dot polyfit, and you can see here it takes your x data, y data and degree. I mean 1 degree, 2 degree. I mean it's a linear one. If it's a parabola type, it's take 2 and covariance. So here you can pass your x data, and you can pass your y data, and you can also give covariance equal to true. Now run the code. So what is wrong? Oh, there should be degree 1, so you can give 1. Now it's fine. Okay, so check it. What is your POPT1 and P covariance 1? So this will the POPT1 gives array of your intercept, your slope and intercept, and P covariance 1 gives the your maybe you can run the whole code, run all, and P covariance gives you a 2x2 matrix, and which is like symmetric matrix. I mean 1 elements equal to 1 2 elements per 2x2 matrix. So now this you got. You can also print or maybe you can print later. Okay, so here you can give or maybe plot fitted lines. Okay, so here you can give say fit underscore line as a variable, and you can give your slope. So slope is your POPT1 and it's a 0th element is slope into x data, and then plus POPT1 1. Okay, so basically this gives your y equal to mx plus c. Okay, now run it, also plot it. So plot fitted line. So for doing that, type here plt dot plot, and you can give your say x data, and you can pass your fit line, and you can give say line width equal to 7, and you can give say color equal to black, and you can also put here plt dot figure and make other one as a plt dot figure 1. Okay, so you can type here plt dot figure to show in the same figure, and here figure 2, and here again you can type plt dot scatter x data, y data, and you can give s equal to 250. You can give say color equal to cyan and run it. So here you can see that your line is fitted for np.polyfit module. So we have obtained the same fitting with np.polyfit, and earlier we did using SciPy CURV fit. Okay, so this is the way to fit. You can also give level equal to scatter plot, and here you can give level equal to, you can give np.polyfit. So you can give line fit such that np.polyfit, and you can type here plt.legend. So this way you can open, and then you can print. So print here slope and intercept, and you can pass here POPT0 and POPT1. So here you have obtained slope and intercept, and then similarly you can also obtain the error in that. So just here error in slope and intercept. So you can take so for doing that error, you need to define your error, and same stuff as here. So error equal to peak covariance 1, and what is the mistake? Invalid syntax. Okay, so error equal to maybe error 1, and then you can print it. Okay, so print error in slope and intercept, or it's printed. So just pass here error 1 0 and error 1 1. So run it, and you can see that you got here a slope and intercept, and you got here error. Okay, so you can compare with previous one. So previous one is error is 1.04, slope is 2.99. So here you can see the same thing, and here error is 0.03 and 2.15. So 0.03 and 2.15. So same value of M and C, and error in M and C has been obtained with two different methods. So using SciPy and NumPy Polyfit. So I hope you got one more method to fit a line using Polyfit. You can also give title. So I'm just giving a title for completeness and copy pasting it. Just here method 2 such that np.polyfit. So this is the way to do the second method, linear regression, and obtain slope and intercept, and also obtain error in slope and intercept. So next will be our Scipy stats method to obtain the same stuff. With Scipy stats, first import from Scipy import stats, and then you can obtain the optimized parameters. Okay, so POPT2, you can tell it, say lin so you type here stats dot lin regress and pass your x and y data. So we have x data, and we have y data. Close the function, and you can run it. What is mistake? X data means x data. So if you like print POPT2, so you can see that it is giving a lot of things. Say this is slope, this is your intercept, this is your R value, P value, it's a error in slope and error in intercept. So this will give those things. Okay, so you can okay, so we have obtain parameters. Now obtain best fit line. Okay, so for that you can define here a line, or you can define line model, or like line model, and you can give here, say your y equal to mx plus c. So y equal to your mx plus c. So you can give m is your slope, so POPT 2. So this is your slope, and m into x. So you can give your x data, and then plus your intercept. So POPT 2 and 1. So this got your line. So this is equation of line. Now plot it. So plot the fitted line. So for that, type plt dot plot your x data and your line model, and you can give line width equal to 7. You can give color equal to you can give you can give color equal to magenta, and you can also plot a scatter plot here like earlier you did. So plt dot scatter. So just copy paste it and put here. Now type here plt dot show, and also type here plt dot figure for a new figure, so that do not overlap. Now run it. Okay, so here you can see that you have a new way to fit a line. You can also give label. You can give as a fit line, such that Scipy stats, and you can type here plt dot legend. So this will be, and also you can give title and xy label as earlier, and you can give your method 3 and call it Scipy extracts line fit, and then you can print. Okay, so print your slope and intercept, or maybe you can print the line model to give everything. So print POPT 2, so like this will give everything. POPT 2, yeah, there should be 2 POPT 2, so everything will be come in this result. So your slope, your intercept, your error, and error in slope and error in intercept. So this is one more way to fit linear regression using Scipy extracts. So now we will be using fourth method to do line fitting using Astropy modeling. Okay, so first we will import Astropy. So import Astropy, and then we will import modeling. So from Astropy dot modeling, import models and fitting. Okay, so this is like used for model, used for 1D model fit. Now we have x data and y data, so we'll now initialize. So we'll now initialize your linear fitter. So initialize linear fitter. For that, type command fit variable equal to fitting dot linear LSQ fitter, and give function. Now initialize. So initialize your linear model. So for that, give your say line fit equal to models dot linear 1D, and give function. Now after that fit the scatter plot. Okay, so fit scatter plot. Okay, so for that, give here best, or say you can give line or best fit equal to fit, and then you can go to line fit, and you can pass your x and y data. So we have x data and you have y data. So this you got. Now you can get the best fit what is returning. So this is returning our slope and intercept. Okay, so you can print here, print best fit, this is like your slope intercept. Now plot fitted line. Okay, so for that type plt dot figure, and then you can copy your earlier escalator plot, not to plot again and again, because every time you have to show the plot. So this is your escalator plot, and then type here plt dot plot. So basically your should give the comment below to that, and so plt dot plot, you give your x data, and then you give your fitted line. So you give your where it is, yeah, best fit. So give your best fit, and pass your x argument, x data. Okay, so now your job is done, and then you can pass the line width equal to 8, and you can give color equal to black, and yeah, so this much. And you can also give a marker size equal to, leave it, just type plt dot show and run it. So here you got, you can maybe change a different color, you can say it's red again. So this is, you have obtained another way to fit your 1D linear fit as a y equal to mx plus c. You can put the labels here. Label you can give Astropy fit, and there should be comma here, and type here plt dot legend. Okay, then you can give your title plt dot title, and you can type method 5. So this is method 4, this is method 4. So method 4 Astropy model line fit. Okay, so this we have obtained linear regression modeling using Astropy modeling. So till date, till we have obtained 3 methods. So one is Scipy, second is np Polyfit, third one is Scipy stats, and fourth one is Astropy modeling. And you got here parameters, slope and intercept. So next is our lmfit. Okay, so we will be doing method 5 right now. Okay, so first import, so library, so from lmfit import model, and then define your define line function. So for that type here definition line, and you can give here your x data, then you want to give point slope and your intercept, and you want to return the function. So return your slope into your x data and plus intercept. So this will turn as a to fit line. Now you want to make model. Okay, so here make line model. So you can give here model equal to model, and you want to give linear model. Now you want to give initial guess. Okay, so give your initial guess to fit. Okay, so for that give here parameters equal to model dot make parameters. So make parameters, and then give say your slope. You can give 0, and you can give intercept as 1. You can give any value you want, and then I want to obtain result for that. So obtain result. So for that just type here result equal to mod, so model fit, and pass your y data. Then you can give your parameters from the initial guess, and then you can give your x data equal to your x data. Now check it, what is your result. Run it and check the result. So you can see that it's a line model. There are least square method. So pure data points to variable, and there's chi-square values, and here is slope, and these initial values, and there is a relative error in that 4%, 5%. So there's a fitted parameters intercept, and there's error in that. Okay, so now fit the line. Okay, so now fit line on scatter plot. So first, like plot a scatter, so I just copy these things and put it here, and then I will plot line fitted plot line. Okay, so plt dot plot, I will give here x data, and then you can give your result dot best fit, okay, and you can give label equal to lmfit line, and then you can give plt dot. So here you can also give marker, different marker than earlier. You give marker equal to a star. Now run it. So you can also give line width you can give equal to 7. So here you can see that you got your fitted line using lmfit. So give a title, so plt dot title, and just copy paste it here, the same thing. So this is your method 5. So method 5, and this is like lmfit run it What is wrong? There should be. Yeah, so this is like method 5 to fit a line and obtain its variable slope and intercept and also in the error. So successfully we have fitted the line using lmfit method 5. Okay, so here's the plot and here's the fit parameters, slope and intercept, their errors, and here's the code to fit a line using lmfit. So I hope you got the method 5 to fit a line on a scatter plot. We will be using 6 method to fit a line on a scatter plot and to obtain its slope and intercept and along with error. Okay, so let's do it. Okay, so first we'll use library. So from SciKit. Okay, so from sklearn. So from sklearn dot linear model. That's dot linear model import linear regression. So this is for regression. Now you want to define model. Okay, so define here model equal to you can define linear regression and pass your function, and then you need to fit a model. Okay, so fit model. So model dot fit. Okay, so this will like give your x data, simply x data and your y data. So this is for model fit. Now you want to generate that model. Okay, so type here model equal to हाँ अभी चल रहा हूँ, आ रहा हूँ. So now fit your model and then do the linear regression. Okay, so type here model equal to linear regression function, and then dot fit your x data and y data. So now you got your model. You can check it what it is. So it's a linear regression model. Now you predict your y. So predict your y values from this model. So type here y predict equal to model dot predict your x data. Okay, so this much we have done, and then you can define your y predict as a line. So define your line equation mx plus c. Okay, so here you can see y predict equal to model and dot here like model dot coefficient, or yeah, so slope coefficient, then into x data and plus model underscore intercept. Okay, so what is the wrong? Model dot, there should be dot. Okay, so now fine. Now this much you have obtained, so you can see what is your y model, y predict. So this is your y predict, this is the value of your fitted y value. Now your plot, so plot line on scatter plot. So for that, type here plt dot figure, and just copy from your this line and put it here, and then type plt dot plot for line plotting x data and then y predict. Okay, so and then type plt dot show, and also you can print here. So you can print here, remove the x data and coefficient. Okay, so here is your here you got your slope, here you got your slope and intercept. Okay, so run the whole code in a single start and run all. What a mistake. So has receive -1. Okay, so you need to define your x data as a receive. So for doing that, you do here x data equal to x data dot receive -1 into minus. So this will like make your a 2D array of the same length. Now run it. X data, y data. There should be -1. Okay, sorry. Okay, now it's fine. Okay, so you can give line width equal to 8. So you got here one more way to fit a line. So you can see that your slope is 0.95 and intercept is 46. Just you can print here, print m and c. So just pass these parameters. So you got here M and C are respectively this. Okay, so I hope you got the idea that how to do linear regression using SciKit learn. So you can give label equal to fit line such that SciKit learn and type here plt dot legend, and you got here. You can also give a title to it, plt dot title, and copy the same title. And this is method 6, it is SciKit learn. So SciKit learn. So this we have obtained its slope intercept using method 6. So I hope you got that how to fit linear regression on a scatter plot using SciKit learn. So we have completed 6 different methods to do this plotting. Okay, so let's check it once again. What is their slope intercept for all different methods? So let's check it. It's running, so you can check it. For method 1 we got slope as 0.97 and 51.96 as a intercept. So in case 2 it is same. Case of third 3 it is also same. For fourth one it is also same using Astropy. So lmfit is also giving the same result, and from SciKit learn it is also giving the same result. So I hope you got the idea that how to do linear regression using 6 different methods, and like this is a very good tutorial compiled in a single video, that how to do line fitting in a single in a single video. So this is easiest way to do plotting. So let's go through the code one by one. This is SciPy CURV fit. This is NumPy Polyfit. This is SciPy stats. This is Astropy modeling. This is lmfit, and this is SciKit learn. So this way you can do linear regression from different methods, and which one is easier you can use for your applications. So I hope you have enjoyed this video to do linear modeling and linear line fitting. So thank you.